Hi, welcome to your lesson on solving trigonometric equations. Exciting topic, great look at all the pieces of trig we've done so far. Let's get started. To begin, we're going to go online. We're going to remind ourselves what the sine wave looks like and also what the cosine wave looks like. These graphs are essential to what we're going to do today. So on here I have a sine wave ready to go. There's a unit circle, and as you may remember, sine represents the y value. Right now at this coordinate here, the y value is 0, so the sine wave begins at 0. But as I move along the unit circle like this, my y values increase, they get higher, and you can see the y values are rising. These y values will keep rising until they get to a maximum of 1, and the sine wave will also be at a maximum of 1 in just a moment. There is the maximum point right there. After that, you can see the y values are decreasing, so the sine wave is also decreasing. Finally, y values get to 0 right here, and the sine wave hits 0, and so on and so on. Then this negative y values, -1 is our maximum y value, and then we keep going. And it continues forever. That's our sine wave. How about the cosine wave? Same thing with cosine, except cosine, if you remember, represents x values. So this time in the beginning, right here, the x value is 1. We're 1 unit away from the center. So notice the cosine wave will begin here at 1. And then it goes down because right now the x values are decreasing. It used to be 1, and now here the x value is less. And it's going down, down, down until right here at 90 degrees. Now the x value is 0 because we're right on the axis. So there's no negative or positive x value, and therefore x value is 0 right here. Cosine curve represents the x values. Then it's going like that. X value now is -1 right here. The largest value can be in the negative side, and then x values become smaller again, 0, and so on and so on. All right, that's sine and cosine curves, important beginning to what we're going to talk about. Okay, so now let's look at this statement. We have this equation, cosine of theta equals 0.4. What does this mean? Well, this means, in simple terms, what angles in the unit circle will produce an x value of 0.4, because remember, cosine represents x values. So we're saying what angles, what unknown angles will lead to an x value of 0.4. We can look at this graphically. We're also going to look at it through just solving. So let's try solving it first. So here's that equation we just saw. Cosine of theta equals 0.4. And now I'm going to go to a graph online and also take a look at it. So here's a cosine graph. And I want to know when are the x values 0.4. But as you may remember, when you see an equation like this, you can consider as two functions, the cosine function and then a horizontal line 0.4, because we're saying when is cosine equal to 0.4? So when is this cosine curve equal to, here's a line at y equals 0.4. So when is this cosine curve equal to this line? Well, what are the intersection points, right? We have these intersections right here. Here's one, here's another, here's another, here's another. And as the curve goes in both directions, we'll have many more points. So that curve is equal to 0.4 at many places. Let's take a look at what that looks like when we solve it. So we are here. Okay, so here's the equation. First thing when we solve equations like this, we are given a domain. We're given all the possible angles because we know the cosine curve will go forever. We don't want to find all those infinite solutions. So we're told just between -360 and 360. We want to see only the solutions that exist between those two ends for the angles. So you can go positive 360 or negative 360. So once around the unit circle in each direction, and then we're going to find out when cosine is 0.4. So first of all, we can solve that. We can say cosine of 0.4. To solve that, we can just use our calculator, right? Do an inverse cosine. Inverse cosine of 0.4 will give you the angle. What is it? Okay, your calculator should produce 66.4. This is a good time to check if you're in degrees and radians. If you got different answers than that, change your mode to degrees, because we're talking about degrees here, and see if you get 66.4 degrees. Okay, now that we know that, okay, you spin an angle of 66.4 degrees right there, and you get to this point here on the unit circle, and we just found out that it produces an x value of 0.4. And you look at that, you're like, yeah, this could be 0.4 for sure. If the entire length is 1, this could definitely be 0.4. Great, so we know that. But there's going to be more angles. What other times is x 0.4? What other angles will x have a value of 0.4? Well, what if we kept spinning this all the way around, came all the way around back to this side, and created one right here? We would have an x length of 0.4 again. So what is that angle? It's 360 minus 66, which is about 293. But that's not all. We can also go not just in positive direction, but also here it says we can also look at negative angles up to 360. So what if we went negative direction? Well, this would be negative 66 to get to here. And then if you went all the way around negative direction, you can get back to here as well. And that would be our fourth angle. So we have the positive one to here, positive one to here, negative one to there, and then negative one all the way back to here, which is negative 293. So we have 4 possible angles to get an x value of 0.4. Let's look at that by graphing as well. So I'm going to double check those on Desmos first, where we were looking. So here's our cosine graph, and we had marked those points. So here they are: negative 66, positive 66, 293. Then there's one here beyond, but again, that's beyond 360 because 360 is right here, right? So I'm actually going to put a line at 360 and negative 360. Look, I put out like a border line. Here's a negative 360, here's positive 360. That's saying that we only are looking at for angles between there, right? So we only have 4 solutions there. This one, this one, this one, and this one. We have those 4 solutions that we just confirmed on the unit circle that happen between positive 360 and negative 360, where the line y equals 0.4 intersects the cosine graph. It's really good to see that connection between the unit circle and the actual graph itself. Now let's do that on our calculator. It's important you know how to do this on your calculator as well. So here's your calculator. Grab yours, and we're going to graph that. So I'm going to press on. I've already pre-entered the function, so y equals. Here's cosine graph, and here's that line, horizontal line, y equals 0.4. I made sure to put my calculator in mode, and I put it in degree mode, because I want to make sure that when it's graphing it, it knows the x coordinates will be in degrees, not radians. And then I'm going to go to my window, and I know I want to see all the way to 360 and negative 360 for my x values. And for my y min and max, I put negative 2 and 2. Graph that. There we have it. There's the cosine graph. There's the horizontal line, 0.4. So we're checking when cosine equals 0.4. And then you can find intersections. Second, calc. Number 5 is intersect. It asks you first curve, it's flashing on the cosine curve, enter. Second curve, now it's flashing on the line, I think. Yeah, there, see? Enter. And now guess means tell me which intersect you're looking for. There's many of them here, but let's go to this first one here. And it should tell me 66. Let's check. There we go, 66.4 matches our answer here. And you can go ahead and find all 4 intersections like that one at a time. Great, really important to know all these connections. Unit circle, graphs, solutions, everything. Okay, let's move on. How about this one? Sine of x equals a half. Now a half looks familiar. Now it is one of our exact values, the ones that are produced by 30, 60, or 90. Here our domain again is given as negative 360 to 360. So sine x equals a half. On the unit circle, this is easy. Okay, so we know that the y value, what angle produces a y value of a half, because sine represents a y value. Well, the y value, well, we know it has to be 30 degrees because across from 30 is a half. So our y value is a half. Where else will we have a half? Okay, keep spinning that angle all the way to here. And then if we create that triangle, we have a half there again. So that angle also works. And then if you go negative direction, you can go negative to here, and then all the way negative direction to here. And you get back to the same 2 places, which are positive half for y value. But there's 4 ways to get there. 2 positive ways and 2 negative ways to spin to that. And there's your answers. Let's check that on the graph as well. So I have a sine graph prepared here. This time, no, that's that one. Let's go to this one. I'm going to shut off my cos graph. I'm going to turn on my sine graph, and I'm going to change this to, what was the value we needed? It was sine is half, so I'm going to put 0.5 in there. And it should graph the line 0.5. There. So now there's the sine graph. Again, there's 360, there's negative 360. So we have our limits of the angle, and here are the angles that give us half. And we can see there's 30 degrees, we saw that. There's 150, there's negative 210, and negative 330. And that matches our 4 angles here that we saw in the unit circle. Great, that's fantastic. Okay, so here we have 3 more problems. Now notice our domain, the angles, the possible angles are from 0 to 2 pi. So we've changed from degrees to radians. So, but we have the same question here. What angles produce a y value of 1/2 on the unit circle? But now our answer has to be in radians. Let's try using our unit circle. So again, we're thinking what y values, when are y values equal to a half? So here's our unit circle. Here is a y values of 1/2, positive 1/2, right? Negative would be here, but we're talking about positive 1/2. Okay, we spin an angle to get to there, to get that y value of 1/2. What angle is that? And then we can spin a bigger angle and also create another one here. So another value of y equals 1/2 there. So what angle is that? What two angles are those? In radians, well, we know this has to be 30 degrees here because across from the half is 30. In radians, that is pi over 6. And this one must be 150 because we have 30 here again, and that is 5 pi over 6. So those are two radian angle measures, and both are from between 0 and 2 pi, because if you kept going all the way to 2 pi, you would never get to a y value of 1/2 again. Those are the only two times we get there. Let's look at that graphically as well. So here I have a sine graph. I have radians on the x-axis this time, and I put these boundaries here from 0 to 2 pi, because those were our conditions in the last one. The domain had to be between 0 and 2 pi. And now I'm going to graph the line y equals 1/2 right here. There's y equals 1/2. So when is the sine curve equal to 1/2? At these two locations, right here and right here. And you can see they match what we just solved. The sine curve is equal to 1/2 at 0.6 and at pi over 6 and at 5 pi over 6. All right, try the next one here. See if you can solve that. When are the x values, what angles produce x values of √2 over 2? Okay, let's check our work here. There's the unit circle. There's an x value of √2 over 2. Okay, both are positive x values there and there. Spin an angle to get there. Spin another angle to go down here. So you have to go either this way or this way, but we can't go negative because this says only from 0 to 2 pi. So you can only keep going positive direction. So this angle, and then keep spinning this angle. What are those two angles? In radians, those two angles are pi over 4 and 7 pi over 4. Pi over 4 right here, because when we see √2 over 2, we know this is a 45, 45, 90 triangle. So if this is 45, that's the same as pi over 4. And if you keep going, that is 7 pi over 4. Great. Try the last one. Tangent equals this. And remember, whenever you see √3, you should be thinking, 30, 60, 90, because it's the only triangle that has a √3 as one of the sides. Okay, so remember, tangent is y over x, so y over x must be √3. That means we had √3 over 2 divided by 1/2, because those are the two sides in that triangle. So, in other words, our y value must be √3 over 2, because that's the top one in this fraction here, and we know it has to be the top here to produce that. So the y value must be √3 over 2. So spin an angle, and then this value here must be √3 over 2. And remember, that is across from the bigger angle, the 60. So right away we know this is 60. Okay, and this must be 1/2. Keep spinning that until you get to here. Why did I choose here? Because we have a positive tangent value. √3 is positive. That means we had to have a positive number divided by a positive number right here. Or if you spin to here, you have a negative number divided by a negative number. So those are the only two places where tangent will give you a positive value, here or here, because here both x and y are positive, and here both x and y are negative. So what are those angles? Well, we just said this must be 60, and 60 is pi over 3. And then if you keep spinning to here, it's 240, so it's like 180 plus an extra 60. That's 4 pi over 3. Everything must be between 0 and 2 pi, so we cannot go, we have to stop when we get here, and those are the only two spots within one spin, which is what 2 pi means here. Within one spin, those are the only two spots where we'll have that tangent value. All right, try this one out. Notice our domain is negative 2 pi over to 2 pi, so it means you can spin positively once around the circle or negatively once around the circle. Okay, so we're looking for x values that produce negative √2 over 2. So here is negative √2 over 2 right here, x values. So we're looking for this point and this point. It's the only two places where x is those two values. Okay, we can either spin in this direction, 3 pi over 4, because you know this is 45. Or you can spin a little bit further to get to here. That angle is 5 pi over 4. Or if you kept spinning positive, you're done because you made 2 pi. But you can also go negative 2 pi, it says. So you can be spinning negatively to get here and here. So that tells you there's going to be two more angles, negative 3 pi over 4 and negative 5 pi over 4. 4 possibilities this time. Try it. Notice we can go from 0 to 720. That means once around the circle or twice. So imagine going beyond 2 pi another time. What would the angles be? Check your work here.